Good afternoon, everyone, and welcome to today's webinar. My name is Klaus Bender. I'm going to be running things in the background. I'm with UTC Member Services. Today, we're going to be talking about private broadband Internet of Things networks, and we're going to discuss utility use cases. Some housekeeping notes, somewhat reverbing. Some housekeeping notes while all the attendees are going to be on mute, and I'm going to make sure that everyone's on mute to make sure nobody's doing it. I ask that if you have questions for our attendees, use the question box in the GoToWebinar interface. You can see it on the right-hand side about 3/4 of the way down on your GoToWebinar interface. I'll take the questions and feed it over into the chat window for the presenters, and we'll deal with it at the end of the presentation. The presentation slides themselves will be available on UTC's Networks platform sometime after the presentation. You will get an email with a link to that Networks community and a link to the survey. Also in the Networks community will be a professional development hour request form. Fill that out and I will send you the PDH. We give one PDH per one of these webinars. So with that said, I'm going to introduce our moderator, Bobby Harris, to take things off, and I'm going to put myself on mute. If you have questions, problems, use the chat box. If you have other things, let us know. Otherwise, Bobby, take it away.
Thank you, Klaus, and thank you everyone for joining us. We've got a great group of people on the call today, and the numbers are going up, so I'm very pleased with that. I am Bobby Harris. I'm the founder and CEO of Smart Water, Smart City, and a lot of you I know from my past life at UTC, so it's great to sort of see your faces again. It's my pleasure to moderate today. You didn't come here to hear from me, though. You came here to listen to the experts talk about utility use cases on narrowband IoT networks, and we'll talk about the networks and devices and the great benefits and some of the important use cases. But let me introduce quickly our panelists. You guys have seen their full bios, so I won't read you all of that, but Jim McClanahan is a Senior Vice President from West Monroe Partners, and since 2013, Jim's been leading their utility work around telecommunications, SCADA, AMI, DA, you name it. Jim's got the expert in it, 30 years of expertise. Next up, we have Kimberly Traylor from JEA. She's the Director of Network and Telecommunications Services, and she's also the lead on the project that we're going to talk about today. So we're thrilled to have her. She's got great enterprise-wide network and telecommunications infrastructure experience at JEA, and we're just thrilled that she's able to join us today, take time out of her day. And then finally, Kathis Kassan, he is the CEO of Puloli, who is also the sponsor of today's webinar. And Kathis founded the company in 2016 to offer private narrowband IoT solutions network as a service model. And with more than 20 years of experience in the wireless industry and 5 patents, you can tell we are going to have a plethora of experience here today. I'm going to let each of our speakers tell you a bit more about their organizations and what they do, of course, and then we're going to have a roundtable discussion after they do a little bit of a presentation here. And then, as Klaus said, we will take your questions at the end. We'll do our best to get to as many of those as possible. But Jim, let's have you kick it off. You know, West Monroe is a leader in consulting for the utilities, and tell us a bit more about what's going on there at West Monroe Partners. I'll get your deck here.
Thank you, Bobby. So West Monroe is a full-service consulting firm with a group that's focused on the energy and utility industry. We do a lot of upfront work around strategy and business case, all the way through project management of projects that are being deployed. And I think everybody here knows that telecommunications has really become a critical part of a robust grid solution out there, improving reliability and safety. Utilities have made significant investments in fiber and wireless networks over the last 20, 30 years. And we've seen AMI get a lot of traction in the last 10 or 15. And we've also seen the ability or the desire to try and leverage the AMI networks to do more. And they look at distribution automation, communications with electric vehicle charging, other distributed energy resources, just a lot of things they'd like to do with it. And to be honest, the AMI networks are kind of stretching at the seams and not that able to support some of the use cases that some utilities would like to see. The great thing about AMI was it had economies of scale. Every meter had a radio in it. It's a lot of radios, so the price points came down, but they were designed to go into meters. And when you started looking at trying to connect them to things like reclosers, capacitor banks, it's possible. It's just not, you don't necessarily see those same economies of scale, and it's kind of force-fitting the network. So we've seen the emergence of a lot of purpose-built networks where for AMI, there's an AMI network. For distribution automation, there may be some overlay network. And the same with the other types. SCADA applications may use MAS radios. So you wind up with all these disparate networks out there that are difficult to maintain. There's a lot of, in terms of exposure from a cybersecurity perspective, a lot of different configurations that you have to watch, updates you have to test, push out into the field, and it's been challenging. IoT emerged a few years ago and has really changed a lot of things. Suddenly we had another technology emerging that's reaching economies of scale that are even beyond what we were going to see with a radio in every meter. And so now the IoT technology, the other real key advantage with it was that it was designed to be flexible in terms of communicating with a sensor and other simple devices, not taking an incredible amount of development effort. You can go buy a development kit off the shelf and integrate it into a lot of different applications. And so we're starting to see that get real traction with the utilities. They look at things like Narrowband IoT. It's enabling a bunch of other applications that they were looking at, they were hoping for, and now are becoming a reality. And in kind of an ironic twist, it's realistic to think that in the future we may see the AMI's application actually migrate back over to something like the Narrowband IoT networks that are being deployed today. And Bobby, if we can go to the next chart, share a little bit about some of the key things that we've seen as we've worked with utilities on business cases and strategies. It's really important to define the current and future use cases and requirements, get those on the table, do a good job of that. It's not unusual for utilities to get down the path of deploying some type of network, and then somebody that's got some new application they've been putting on cellular shows up and says, hey, we'd like to get on your network. And if that wasn't planned for from the start, it's just additional challenges. You start tweaking things in that weren't meant to go in. You can make a better decision and a better business case up front if you really spend the time talking to all the groups and everybody about what they're doing today, what they see coming up in the future. It is important to define that future state telecom vision. Where do you really want to be? And not just a year from now or 5 years from now. A lot of times we'll talk with utilities about where do you see things going 20 years from now? And when you start thinking that far out, you get a much different, more robust view of the world. And what you're going to do in the next 3 years may not play directly into what you see wanting to be 20 years from now, but it gives you a better plan that gives you steps along the path, or a path to get you step by step towards that end goal. We do think it's a blend of technologies. There's no one technology that's going to do all this, but at the same time, you want to be getting away from those purpose-built networks. It may be 3 or 4 technologies that you wind up with, but that's a lot better than having a lot of large utilities have 20 or 30 different types of telecommunications networks with fiber and cellular, MAS, the AMI network, maybe a couple of generations of AMI, and other types of solutions that are out there. They get overwhelming after a while. We also think it's very important to be business case driven. If the economics don't stand up, and if you haven't done a good job of defining what the budget's going to be, how long it's going to take to build this out, the staffing that's going to be required to support it, you start getting into this cycle of every year you show up and you're asking for a little bit more money to build a little bit more of the network. What we found is the decision makers and the executives would much rather have a roadmap that shows here's a 5-year vision. Here's what we're going to do over the next 5 years. We're going to build this in year 1, this in year 2. We're going to need to staff up. We're going to need these capabilities, and have that clear path defined up front. Go in for approval of the overall project, not go in for annual budget approval. Benefit realization is another thing where we see big challenges. A lot of utilities put networks in place and they have great aspirations about what it's going to do, but nobody's really keeping score on did that happen or not. And it's really important because these networks do offer a lot of benefits, and if you track those, it gives you additional credibility for the other decisions that you're going to be making and projects that you'll be pushing down the road, but also some chances sometimes to find out early on in a process that maybe something isn't going quite like you should, and you'd rather, or you'd hope. And it's better to know that up front, be honest about it, and look for ways to deal with it than it is to be surprised by that down the road. The other thing that we're really seeing out in the market right now is be open to creative alliances and partnerships. Utilities like water utilities and electric utilities, working together with your vendors, working together with carriers in some situations, or maybe other potential customers that would look to you and want access to your network and be interested in you being a network as a service provider. There's a lot of different business models that are being looked at, and given the times right now and the challenges, the budget challenges that some companies are having, that creativity can really get things out on the table that nobody would have thought of if they just stuck to their own little silo. So that's a little bit about what we're seeing, and I'll turn it back to you, Bobby.
Thanks so much, Jim. I really appreciate your insights there and West Monroe Partners work for sure. Kimberly, you're the project lead at JEA on the projects we're talking about. Share with us what you've been thinking through.
Absolutely, ma'am. Next slide, please. Good afternoon, everybody. I'll share a little bit of information about JEA. For those who are not familiar, we are an electric, water, and wastewater utility located in Northeast Florida. We service about 1,200 square miles between 4 different counties. And I would say that in the world of network and telecom, I'm a pretty lucky lady because we own and operate our own fiber network, approximately 700 plus miles. We also have 40 communication towers, which were initially installed, some for SCADA and then others when we ventured into AMI in the early 2000s. We run multiple networks for licensed and unlicensed 900 megahertz and 6 gigahertz microwave links, some point to point, some point to multi-point. We also are using quite a bit of cellular today, supporting some of our initial IoT use cases, primarily fault current indicators and other pressure temperature sensors in the field. We use wireless routers quite a bit and are in the process of rolling out our vehicle area network with 1,100 units that'll be in the field. My group supports substations, water and wastewater plants, our larger class 3 and class 4 lift stations with fiber, all of our service centers, corporate offices, and all of our field area networks. And currently today we have Landis & Gear as our AMI network partner. We have about 35 collectors and 3,700 concentrators that support our service territory. Next slide. So back in 2019, JEA began working with several pilot technologies as part of our data lab. And we really wanted to address an issue that's been plaguing us and many other utilities for some time. Over the years, we have built multiple disparate networks that were purpose-driven for a specific application. So today I'm left with 28 plus disparate networks, which is quite a bit when you look at consolidation. and most of them are incompatible. And as part of our considerations for the next generation digital grid, we began to look at LTE-based technologies. So I need to support almost 1 million field endpoints today, and we're expecting that to grow at a more rapid pace. And we really needed to develop a multi-year telecom strategy, which I feel is going to be critical to JEA's digital grid success. So probably a little over a year ago, we actually partnered with Select Spectrum and Puloli and started taking a look at Narrowband IoT. And this is our first soiree into really using LTE outside of the carrier community. And just to set the baseline, we did some ambient conditions monitoring at several of our locations, just getting basic information for temperature and humidity. We primarily use that to establish the RF link and take a look at the performance baseline before we added additional use cases. Then we moved into something for those in the network and telecom community. Generators are pretty important to us, especially in Florida. And this year we've had a tremendous amount of rainstorms and hurricanes. So we figured that that would be a good case for us to take a look at. So we started getting generator diagnostic information utilizing CAN bus as the interface. And that has worked really well. A lot of our field personnel that are able to take a look at that data and take a look at trending information so that we're doing preventative maintenance on time. And then the last use case that we have right now is we partnered with our water team, and we are we're doing actually pressure transducer monitoring, which today we currently use the sensor through a PLC and a SCADA gateway. And then we did a side-by-side comparison on the NB-IoT pilot, where the sensor is direct over NB-IoT to our tower, and then it takes fiber backhaul to our OSI Pi platform on the back end for comparison. And one of the things that we found that was pretty interesting is when we were looking at the baseline data and taking a look at our initial pressure transducer, we were off by 8 psi on our side. So it was interesting to find that. The endpoints can be deployed separately from the PLC and the SCADA interface. And just a few problems that we were looking to solve by utilizing this sensor. For the boiled water alerts, for us, identifying those leaks sooner and being able to fix them allowed us to really narrow down the boiled water notices, which is important to our customers. And then for the leak detection, that faster response, of course, you know, the faster that we're handling the leak, the less damage and the less impact to our customers. So customer satisfaction is something that's really important to JEA and keeping any outage time down for customers. And then the last one was really around kind of managing our consumptive use permits. JEA developed an application where we take this information into our Oscar system, and it allows us to optimize the grid for the water side of the house. So it's been very successful so far, and we're seeing you know, a 25-mile radius from both of our towers. We've got equipment located on a 480-foot tower and a 300-foot tower. And it was interesting that we were actually seeing coverage from Florida into South Georgia. So I would say so far, all of the use cases have been very successful, and we look at doing possibly some additional use cases with Puloli around SCADA and possibly some AMI.
Great, Kim. Thank you for that overview. I know we're going to have a lot more questions because that was some important information that you gave us. So we'll dive into that a little bit more in a bit. But first, let's hear about what Puloli's solution is bringing to the table from Katis. Katis, you're muted.
All right, thank you, Mary. Hi, everybody. Thanks for that intro. We are glad everybody could join us for this webinar. We are very excited to talk about what we have done in the JEA, in partnership with JEA and Select Spectrum in Jacksonville, and want to give you a quick overview of the system architecture and introduction to Puloli, and then we will pivot into in the details about the use case. So Puloli, we are a network as a service company. What that is essentially we offer full turnkey, fully integrated end-to-end private IoT networks for utilities and critical infrastructure industries, broadly speaking. It is a 3GPP based LTE IoT standard, specifically in this case NB-IoT. We design, deploy, and manage and operate the network on behalf of our customers. And goes without saying, it operates on licensed spectrum, and it comes with the LTE security framework and the security standards that are inherent to any LTE systems. Next one, please. So this is a high-level overview of our system architecture. The center of the universe for us is the base station that sits in the shelter next to the tower. On the tower top, there is a remote radio head and panel antennas, and we typically do the standard 3-sector cellular design. As far as the frequency bands go, it can range from 450 megahertz to 2.1 gigahertz. In this particular JEA Jacksonville deployment, we are using the upper 700 block, 700 megahertz A block in partnership with Select Spectrum. Kimberly mentioned the long range capability, reaching all the way into Georgia from one of the locations here in central Jacksonville. The NB-IoT allows the range up to 25 miles, so we were able to verify that in the Jacksonville network, and it is the NB-IoT standards and the network design combined that allows us to reach that distance. As far as the endpoints go, we have made a couple of announcements in the recent past, announcing the support of Qualcomm-based chipsets, as well as last year when we launched the network, we announced the support for Sequans-based chipsets and modules. We plan to make further announcements, additional announcements later this year and into early next year, announcing more module vendors supporting interoperability and FCC certification to be operating on the upper 700A block. We will talk about some of the custom assets and details in a minute. One quick thing I wanted to say about the previous thing is that the EPC typically can be deployed in a cloud setting or on-prem together with the base station, and it can interface to pretty much any IoT platforms that are supporting TCP/IP and UDP/IP transport layer. Kimberly mentioned earlier that in the JEA deployment, the IoT platforms are the OSI soft PI systems that JEA has in their internal networks. Next one, please. The two things I want to add to this, in the map that Kimberly showed you earlier, you can see that these two locations from these two tower sites, we cover vast majority of the service territory of JEA. There is one tower location on the northeast side and another one on the southwest side. And this is, as I mentioned earlier, is on the upper 700 megahertz A block. This is a world's first ever private NB-IoT network, purpose-built for a utility on a licensed spectrum, operating on the NB-IoT standalone mode. So we are glad to have that bragging rights. We expect more of these to come along in the future as the momentum is building around NB-IoT for utilities and critical infrastructure, not just here in the US, but essentially it's a global phenomenon now. Next one, please. So I want to delve a little bit more detail into the water pressure use case that Kimberly mentioned earlier. I want to contextualize relative to a problem statement and a solution. Generally speaking, the problem statement is that there is a need to deploy additional monitoring locations in the water distribution line. And SCADA is not available in many places where there is need for monitoring. If there is no existing SCADA or no power AC mains power access, and some RF coverage for the SCADA network is not available. And in other cases, there is a desire to put it in non-utility locations to give a complete map of the water distribution line. And the other requirement is obviously it has to be a highly secure and very reliable network, and it has to be inexpensive and a very quick and simple installs. So against that problem statement, you can see how very well NB-IoT solution fits in as a solution. And it's a long-range network, low-cost endpoints, battery option to if needed. It is compact and a quick install. So we are very glad that we were able to demonstrate and operate this use case. You can see the diagram on the right side. The sensor is a T-junction where the water pressure transducer is installed, and it connects to the small compact remote unit inside the box you see on the wall. Next one, please. Thank you.
These and Kimberly and Jim. So what we're planning to do now is just really open it up as sort of a fireside chat. So if everyone will turn their screens back on, and I'll do the same for a moment because I like seeing faces as well. You know, we talked a lot about this, what it could do kind of to complement the SCADA solutions. And Kimberly, you shared some really good information, and I know you've been working on that around your water pressure monitoring. And how we'll do this is I may address it to you, Kim, but Jim and Cadiz, I would really like you to chime in as well. But Kimberly, if you could just kind of, how do you see NB-IoT perhaps being a complementary solution to SCADA, or an evolution, if you will, to extend SCADA?
So for myself, I actually have three different networks. So we're looking to not only consolidate the number of networks that we have, but support multiple endpoints. And I think the one thing that Cadiz brought up is our service territory is pretty vast, and we don't have connectivity everywhere we would like to have it. So being able to provide that connectivity and these endpoints at a reasonable cost, I think is going to be transformational for JEA going forward.
That's a good point. Jim and Cadiz, jump right in and share your thoughts on that concept.
I do think, you know, one of the things about SCADA is that there's core SCADA applications that are going to be on traditional SCADA networks going forward. But the idea of augmented SCADA, getting more data points, more information out there, ultimately what the SCADA system needs to do is provide operators with insight, both real-time insight and hindsight, you know, looking back at what happened, events, and how we can better manage things going forward. And if you look at being able to pull more of that information in and you take that into account, at the same time, things like machine learning are advancing so quickly, there's a lot of opportunities down the road, and more data is better as long as it doesn't overwhelm you. And I think machine learning is one of the tools that's going to help make sure that we don't get overwhelmed. So these sensors, there's a lot of them are going to be out there, I think.
Yeah, I think that a big thing for us too, Jim, even when we started off with our fault current indicators, the data was more of a nice to have instead of something that was critical. And I think that, you know, these endpoints are going to become more and more critical in the decision making and operational processes going into the future. And whether it's machine learning or advanced automation, that they're going to be able to support that through this data collection process.
Yeah, and I would echo all those points. And I would one thing I would add is that the complementary nature of NB-IoT to the SCADA, foundational SCADA, what Jim was referring to earlier. One of the things we're beginning to realize is that there are I'm echoing and repeating some of the things that Kimberly and Jim said, but at a generalized sense, we are a complement. The NB-IoT is a complementary app to extend the SCADA capabilities to locations and endpoints that are currently not SCADA connectable. Number one. Number two is that anytime you want to scale to a significant number of endpoints, I think that's another way NB-IoT can help extend SCADA in terms of having lots and lots of low-cost endpoints that don't require heavy lifting in terms of PLC SCADA. Having to be in every location. So anytime you want to get those remote endpoints connected to the existing infrastructure, connecting back into the existing backend of SCADA backend, this is an excellent way to extend the range and reach of the SCADA framework.
Yeah, that's a really good point, Cadiz. And you talk about that scale. And Jim, you had mentioned all of the different use cases and the opportunities for narrowband IoT there. If I can turn it back to you a little bit to kick us off talking about this concept of what they would call massive IoT, or that IoT at scale that we were just talking about.
Sure. And I think utilities, as we deploy this, I've been in telecommunications with utilities over 30 years, and we kind of know what we know, but we don't know what we don't know. And as we look at some of the applications that are out there, it's interesting. We were looking at for utility how they could potentially leverage their AMI network, and it turned out the AMI network wasn't capable of. We identified some interesting use cases that really were part of the core business, and they were useful to utility customers and valuable to utility customers. One example was refrigeration monitoring for commercial refrigeration, and they'd had a situation where a commercial refrigerator had failed, the restaurant had lost a lot of food that had gone bad, and it cost them significant amounts of money. And if for some kind of sensor that could pick up and detect that was going on, and let them proactively notify the customer that, hey, you've got an issue with refrigeration, would have been huge. Another situation we found at that same utility involved some issues. There had been several accidents at railway crossings, and they were very sensitive to that and looking at that. And it turned out that they had a situation where the railway crossing wasn't operating. It basically didn't have power, but they were showing that it had power to the meter, which is generally where they stop. But having that insight that there wasn't power inside the building, that something was going on between the meter and the building, would have had a lot of value to them. And when you can start doing that for a few dollars a month for some of these endpoints, there's so many other things. And when you look at like maybe trying to augment this with automatic meter reading for water utilities, things like leak detection or basement water sensors, there's just so many applications that when it becomes cheap, feasible, scalable, like the massive IoT, I think utilities are going to find a lot of things that tie to their core business that they really just never thought of before because they didn't have a network that enabled those opportunities.
Right. Well, and I think the one other thing that even we're looking at a lot of other utilities is, additional revenue streams. So looking at what's going to happen in the future, kind of behind the meter, to enable a lot of those use cases as well.
Yeah.
Yeah, and I would echo that to what Kimberly said. And in the diagram, you're going from the right to left. The behind the meter services is going to be an exciting opportunity for the utilities. And we here at Puloli, we are excited to support those use cases because that's very sweet spot for NB-IoT profiles. So one of the key things as you go across all of these examples we call out in the slide, the common denominator across all of them is the appropriate traffic profile. That's a sweet spot for NB-IoT. So you will see that the pattern is that it's a normal reading, and then all of a sudden there's an anomalous condition and you want to trigger that. So that's and with the some data encapsulating the describing the situation that's just happened. So that's an ideal condition for NB-IoT, and the behind the meter services that are potential for additional revenue for the utilities. A very good example where whether it's a home security, here climate monitoring, congestion pricing, demand response, you name it, right? You want a secure, reliable, indoor penetrating technology that you can count on. That is, when the power goes out, when the Wi-Fi and the broadband goes out, you can still reach that and control the behavior. So that's very important from a reliability point of view. So we are very excited about the behind the meter services as an example. And if you go from left to right, from electric to water to gas, you will see there are quite a few use cases from DA to FCI to cap banks and fault monitoring and all of that. There are lots of cases where you have to have a small bursty data every now and then, periodically or event driven, that needs to be sent and received for measurement and control. There are quite a few of these use cases in this category that fits into NB-IoT. And the last one, really, I want to say quick plug in for is the DER, distributed energy resources, and the microgrid nature of the future is a sweet spot for NB. Again, that's when you have tens and thousands of these endpoints, and you want to scale and gracefully scale and be able to securely and reliably trust the data coming from those endpoints for microgrid management is key. So the trust and security and reliability on your own spectrum using a trusted technology is key, and that's why we are very excited about NB-IoT at scale here across many different use cases in the utilities.
Yeah, and even these in the limited number of use cases that we've put out in the field so far, the reliability has really been carrier grade reliability that we've seen for NB-IoT. So that's been great, because that's something that's so important to us. And like I had mentioned before, a lot of the data points that we've been collecting for IoT initially were nice to haves, and now the business is really starting to operationalize those. And I think the more data that they have, the more automation that we're able to put in place through AI and machine learning. It's just going to continue to be provide that reliability and resiliency we want throughout our grid going into the future.
Yeah, that's absolutely critical. And I think, Jim, you alluded to this earlier. 10 years ago, we saw the evolution from AMR to AMI. And now today, we're seeing the next generation AMI opportunities come. Kadis, how would you characterize what Puloli is doing for the next generation of AMI? Because it really goes back to that, bringing the right amount of data the right way, the right time.
Mm-hmm. Yeah, I think we are excited about the possibilities of helping out the next gen AMI evolution. In the past, the state of the art has been is to have a proprietary network, and Kimberly alluded to a couple of examples, and Jim mentioned a couple of those as well. And they were purpose built for that purpose. In some cases, over unlicensed spectrum, in other cases, a narrowband licensed spectrum. There is also, in some cases, in the US and outside globally as well, to use public cellular. But when you go with public cellular, there's a cost issue, but you also don't have a control over it, technology evolution, and the longevity guarantee. If you want to have a 15-20-year guarantee of the radio module you're putting in there, is going to work for that long. So you don't get those guarantees in public cellular nowadays. And then if you go with the proprietary solution, you're locked in with the particular vendor, and then there's a sunset issues and product support and all that. And we also have seen some pull only model where the data reads can be complicated and cumbersome, architectural protocol challenges and so on. Whereas if you fast forward, if you look at the next gen AMI and what can happen if you're going to use the NB-IoT network for this purpose, yes, you have to design the software to be an NB-IoT profile friendly for sure. And some cases, particularly outside the US, there is a tendency now to do a multi-RAN design so that you have fallback to other radio connectivity options in addition to NB. But regardless, NB as an anchor for next-gen AMI makes a lot of sense with the proper traffic profile built in, designed in from a software design point of view. with that, what you get is, the carrier-grade, high reliability, robust multi-vendor ecosystem that has a downward price pressure that's beneficial for utilities, and you no longer beholden to one particular vendor, because now you can plug and play different radio modules because they are standard space. That's why we are very eager to encourage a healthy ecosystem during many different suppliers providing chipsets. And that all of that leads to much lower cost of TCO. Unit TCO is much more attractive now if you do that right. The one other thing I forgot to mention in the slide is the battery operation, battery operable friendliness to NB-IoT, particularly when it comes to gas and water meters. NB-IoT, as you probably know, was designed for this use case in mind, not only for range, but also reducing the current range, so the battery life can realistically be done for 10, 15, 20-year horizon in mind, if you have the proper software design and the network design coupled for these meters. So we are excited that we can not only obviously address the electric side, but the same network can be used for gas and water meter reading as well going forward. And it's bidirectional, right? You are no longer constrained by this pull-only model. You can have a much more modern application framework where you can do asynchronous and synchronous subscribe and response and request and response models, as well as the traditional push and pull model. So there are a lot of flexibility on the application side. So we are excited about the potential of playing a role, NB-IoT playing a role in next-gen AMI.
Yeah, I think we definitely have some opportunities there. We're running two-way electric meters right now. We're about 100%, I think, on the electric side. We finished the last of our rollout earlier this year, but we're running one-way on the water side. And we really struggle with kind of out of our core county, outside of Duval County, so those fringe counties to the north and south and west of us, where we don't have that electric infrastructure. There's definitely some opportunities for us there. And probably one of the biggest things is our current infrastructure is, like you were talking about, vendor lock-in. It's very proprietary. It doesn't allow a lot of flexibility. So for us, kind of going into the future, we're really looking for that flexible, interoperable solution that we can run, lots of different endpoints over a single network, regardless of the use case type, whether it be electric, water, or wastewater.
We've seen, the AMI vendors have talked about standards like YSUN, and they've worked at getting there, but they haven't got there in the kind of timeframes that they were originally communicating to a lot of the customers. And I've been in more discussions this last year with utilities that are really starting to think about, I got to start thinking about my next generation AMI network, because am I going to stick with the existing vendor that I'm working with and trust their evolution story? And if so, are they going to deliver on that story better than they've delivered on some of the past stories? Or I'm going to start looking at migrating towards something else. And it's a very real decision for utilities. It's going to be a very painful and tough decision for some utilities also. But this is something that a lot of utilities are starting to realize they need to get out in front of in terms of having a plan and an opinion on where they need to go.
Yeah, totally concur.
Absolutely. So we've had just a ton of questions come in, and I want to respect our audience and try to get to as many of those as possible. I've been trying to collect those here. So I want to ask first, someone asked about the network as a service model. Is that really considered CapEx or OpEx? How are you seeing utilities utilize that? Now, I think, Cadiz, perhaps since it's a Puloli model, perhaps we start with you on that one.
The answer is yes, both. So it depends, and we understand different utilities are different, and probably there's no one general answer. But in some of the cases where you are tied to a rate case, you have to capitalize it, and other cases you have the flexibility to do an O&M or a recurring OpEx budget. And there are other creative options in between too. So we are flexible, but fundamentally there is there's a financial structuring aspects of it, and particularly if you have to tie to a rate case and so on. And then there is the paradigm shift model that's going on. And then the third leg of the stool for the network as a service is what do we really do behind the scenes in terms of technical and operational details. So I address the rate case and the budgeting aspects of it, which is there are 2 or 3 different possibilities we can work with. And then on the operational technical side, the model is essentially we bring in all the software and hardware, and we work with you to understand your coverage capacity and the traffic ramp up models, and the one that the paradigm that Jim was describing, and then Kimberly was giving some JES specific examples. So over your 15, 20-year horizon, what is the traffic model going to look like? So we design and optimize the network accordingly. And so that's the SLA, that is the network as a service is guided by. So that's the operational aspects of it. I'm sure Kimberly and Jim have their own take on it as well.
Yeah, for us, of course, we're continuously trying to drive out O&M cost. So for us, probably a capital model would be more attractive to JEA. But I think that, it really depends on each utility, how they would apply it.
We are seeing, regulators have looked at this on the investor-owned utility side. There is the carriers, actually the cellular carriers over the past few years have really pushed regulators to consider things like capital leases. So there are some regulatory movement towards models that don't push utilities so strongly towards maybe capital, huge capital investments, if that's not something that's going to deliver the most value in terms of total cost of ownership. And something like a capital lease, you may be able to amortize the capital out over annual payments and still achieve some of the benefits. So I would say that pick the right technology and communicate with your regulators. And if regulators want to force you down a particular financial structure, they can do it. But it seems from our interaction with utilities and those utilities' interactions with regulators, I think regulators are much more open to, again, getting back to creative discussions, creative business models, creative partners. I think a lot of regulators want to be partners with the utility and making sure that the next decision or the capital decisions, investment decisions are ones that make the most sense for the customers over time.
Absolutely.
So we had a question about from JEA's pilot, was the 3 use cases in service simultaneously and what bandwidth was required? And then we had a separate question that is really together, so I think you can answer them together. It's about how much spectrum is needed for narrowband IoT. So those two seem to kind of go together, and I'll let you guys address those.
Okay, well, so actually the 3 use cases are all in service today. Initially, we kind of built on each one. So we did the baseline with the ambient temperature monitoring, and then put in the generator monitoring, and then last was the pressure transducer sensors. But today they are all running in a QA environment and going back into our data lab. In regards to the bandwidth, Kathies, maybe you can speak a little bit to that, as well as the spectrum.
Yeah, no, definitely. So the NB-IoT fundamentally is a 200 kilohertz raster, 200 kilohertz channelization, right? So you have a 200 kilohertz up, 200 kilohertz down FDD mode, or that's the A carrier. And in this 1+1 scheme, 1 megahertz up, 1 megahertz down, that upper 700A block has, we can fit up to 4 carriers in there. In terms of the bandwidth needed for these 3 concurrent use cases, single carrier was more than sufficient. Well, quite a bit more than sufficient, because as I was describing earlier, the NB-IoT profile is that there's a defined cadence of regular measurements that goes up, and then only anomalous events that trigger the asynchronous send of data. So one single 200 kilohertz carrier was sufficient for those three at this point. It is very efficient when you operate NB-IoT and its sweet spot, that's by design. So that's how NB-IoT scales in terms of large number of devices to be serviced in a small in a single cell sector carrier design. So I don't know if that answers this person's question, but the bottom line is that single 200 kilohertz carrier can do this kind of traffic profile.
Great, great. Yeah, thank you. We have another pretty specific question, I think, really about the IoT ecosystem, if you will, of vendor technologies. So perhaps a little bit of discussion, maybe Khadis kick that off. I know you alluded to it a little bit with the Qualcomm announcement, but a little bit about the ecosystem. And then Jim, maybe chime in about if you're seeing some growth there.
Yeah, I haven't actually read the question, but going by what you just told us, Bobby, so if the question is about ecosystem and the richness of the vendors coming into supplying equipment here, so worldwide, Qualcomm is the leader on the chipset side, where it's a known fact everywhere. They pretty impressive set of portfolio in terms of what they have offering for both, just not on the IoT, but also in LTE and 5G and so on. So we are very glad that they are on board in supporting this particular spectrum. And then Sequans, based out of France, they have been supporting us from last year as well. So that's the underlying silicon, and then from the silicon there are various whole set of module vendors who build a more completed framework of a hardware platform that can easily go into whether it's AMI meters or the endpoints like we did at JEA, water pressure monitoring and other use cases. They can also go into various other purpose-built endpoints, and we will be announcing some various third-party end-to-end application providers, from anything from vibration sensors to monitoring anything that motorized and moving components can be maintained for long-term preventive maintenance. Gas monitoring, ambient monitoring, all end-to-end application that can transparently go over NB-IoT. So those endpoints are also based on Qualcomm or Sequans-based chipset inside. So that's on the device side. On the network side, we have the specified channelization scheme to take the standard LTE NB-IoT standard and map it into this particular frequency band. So if other vendors wanted to provide network side solution, that's definitely feasible. I know there has been effort in the past to bring more vendors into the space, and it's quite possible in the future more network side vendors will support this frequency band as well.
And we do see, a lot of the vendors on the AMI side, especially on the water AMI side, we're seeing a lot of vendors interested in moving towards a narrowband IoT type of solution. On the water meter side, particularly, they don't have the expertise around RF networking and some of the details of the integration work, being able to buy development kits or being able to outsource parts of the development to people that are experts in this area that can come in, do it quickly, do it efficiently, do it right, is something that's definitely got their attention. This is something that it's playing well, because there's going to be so many different options in terms of the network, and you can pick the one that's right for you, whether it's a carrier network, whether it's a private network. The underlying technology is the same, and that's going to drive economies of scale. Ultimately, that's good for everybody.
Yeah, absolutely. We have tons of questions. So for all of you on the webinar, I know UTC will share those with us, and I apologize if we don't get them all addressed today, because we're coming close to the end of our time here. But one thing you guys had talked about, and Kim, I heard you talk about this in the past, and maybe as a wrap up, we kind of give some thought, and then you guys take this wherever you want to go with, really around the telecom as the fourth grid. Share with us what you're thinking about that. That's just really intriguing to me.
Yeah, so traditionally, telecom was really seen as a supporting service, and over time, it is, as critical now to support all of the current state and future state use cases for grid modernization. So inherently, it almost becomes its own grid. So we've been calling it the fourth grid, and I'm trying to get our senior leadership on board with that, because to be able to do the things that we're going to need to be able to do in the future, for enhanced automation, for machine learning, for a lot of these different use cases, a really robust telecom posture is really going to be necessary. A secure and a lot of the things that Jim mentioned early on with these disparate networks, we don't have the same type of insight that we're going to need in the future. I mean, luckily today I've got a great group of engineers. However, where we're going to need to be in the future, especially when you start talking about microgrids and the utility accepting power from homeowners, is the power clean? Can we accept it? You're talking about the latency in the milliseconds. And so the importance of that telecom grid is just going to continue to increase. And I think having a clear strategy going into the future and being able to bring along a lot of these legacy technologies and having kind of on and off ramps in that strategy is going to be important.
A lot of electric utilities, I mean, they've got thousands and thousands of miles of fiber out there. So there's lots of fiber. There's been talk about how can that be leveraged for things like bridging the digital divide or providing rural broadband. So when you look at it, really utilities are looking at this from one end of the technologies, the fiber, down through things like private LTE that they're looking at today that they could potentially offer a network as a service or partner with other utilities, down to the narrowband IoT types of applications. The concept of an overlay network and that network being shared between municipalities for smart city applications, utilities for meter reading and automation type applications, end users that are wanting certain types of monitoring, makes a lot of sense. And again, this is something where, in talking to some of the regulators in some of the states, you're starting to hear more about there ought to be ways to leverage this investment. You need to make it on behalf of the electric customers to provide reliable and safe electric service, but there ought to be ways to leverage that for some of these other benefits to the customers also. So regulators are also stepping in and saying this makes a lot of sense to consider this. The fourth grid, I see a comment about the third grid, or we've seen it referred to as the telecom utility. There's obviously some sensitivities around that because there are the carriers out there that would argue that that's what they do today. Right. But at the same time, I think there's probably nobody would argue there's not room for improvement there.
Yeah, and I would add one other thing just as a closing thought. I think the diversified revenue for the utilities to have additional revenue from this investment they're making on a private network is quite interesting, because I think they could turn this into not just from a broadband or a traditional telco service provider, but more importantly, an IoT service provider, because the cities and municipalities that you are in your service territory are natural customers for you, to anything from, the places where you don't really, obvious ones are the street lights and commercial buildings and various other municipal agencies in your service territory are natural customers to offer IoT services. I think those kind of additional revenue sources can be really built up, because I think those are the verticals where the traditional carriers and telco operators haven't done a very good job in making fully integrated end-to-end in a turnkey model. Since you are going to embark on a turnkey model, it's a natural thing to offer a complete package solution to the municipalities, cities, and other utilities that are not not yours. So let's say you have electricity and gas, but somebody else has water, then you can provide this service to that water utility in the area, for example, and all the cities and municipalities. So I think those possibilities are very exciting longer term, because that has a potential to turn what traditionally has been a cost center into a potentially a profit center.
That's what
So
my
I
mom
know that's a holy
here.
grail. That's a bit of a stretch right now, I know, but I think looking at that big picture and having some long-term vision is key as you make some decisions on making investments in these kind of private networks.
Yeah, absolutely.
Well, and I agree totally. You know, clearly there are tons of options, tons of use cases. Personally, I'm thrilled that we talked water use cases and smart cities, because water always gets left out of the smart cities conversation. So I want to thank you guys. We are completely out of time. Klaus is gathering the rest of the questions, and we'll do our very best to follow up directly through UTC. We thank UTC for producing this for us today. I thank all of you for taking the time to share your expertise. This is new, but utility telecommunications infrastructure and smart city work is critical to the future of all of us, whether you're in rural America or our urban cities. And I think we have some great opportunities to push forward. So thank you all today. Thank you to everyone who joined, and I hope you have a wonderful rest of your day.
Thank you, everybody.
Thank you very much.